Audio test. One, two, three. Ok. Let's just wait for someone to join. Здравствуй, Лиза. Давай поиграем в спиритический сеанс. Видно ли меня, слышно ли меня?
Меня.
Ну, у тебя там адский шум на фоне, судя по развивающейся шторе, это ветер. Вот, но твой шумодав в целом справляется.
А сильный шум? Я тогда сейчас
Теперь
выключу
норм.
ветер.
Не-не-не,
Так,
сейчас норм.
он открыл письмо, но пока не идет.
Найс, у меня кружка с драконом. Кода рисовала.
Крутяк.
Да.
А получается, у нас запись уже идет, да?
Давно. Уже
Окей.
15 минут как. Так, я пока открою вопросики.
Насколько я поняла, он не смотрел вопросы, потому что он такой, типа, я ему скидываю вопросы, говорю, вот, типа, вот мы столько их сделали, давайте вы ответите на те, которые вам нравятся. Он такой, типа, нет, давайте вы мне зададите те, которые вам нравятся. Я ему пишу, нам нравятся все, будет круто, если ответите на все. Он такой, окей. Но вот эти
Посмотрим.
клики на открытие файла у меня не затрекались, поэтому, возможно, он их реально еще не смотрел.
Вот, Николай Рубанов там пытается что-то сделать с вопросами, но что у него получится, мы увидим через неделю-две. Или не увидим, если у него не получится.
А может не получиться?
Конечно, но это вообще довольно тяжело.
Ну да, я
Ну,
понимаю.
знаешь, как художественный рассказ написать, ты садишься вроде, ну, блин, что там писать, любой ребенок справится, да, начинаешь писать и неожиданно понимаешь, что не можешь. Ну, вообще непонятно, что писать. Ты так, вот тебе факт. С вопросами то же самое. Ты берешь какого-то чувака из индустрии или чувиху, который что-то интересное делает. Да вопрос любой студент напишет, сейчас я сяду
Да,
и
конечно.
неожиданно понимаешь, что кроме «привет, как дела?» спросить особо нечего.
Ну
Вот,
это круто, что ты
поэтому
придумывать так можешь.
таки да, может не получиться. Но вот на меня, к сожалению, набежала работа в больших количествах, поэтому я больше придумывать не могу.
Может быть, ее станет поменьше там к зиме когда-нибудь.
Нет, она фундаментально удвоилась. То есть пришел Путинцев и сказал, что раньше у нас будет 3 митапа в год, теперь 12. Готовь, пожалуйста, спикеров. А это гораздо сложнее, потому что если на 3 митапа спикеров можно найти, ну то есть у меня 92 евроновца-разработчика в карьере. Вот, если я могу среди 92 людей, ну, достаточно несложно найти там, по одному спикеру в год, то когда тебе надо 12 спикеров в год, их неожиданно уже нету, поэтому ты не можешь их просто искать, тебе надо их выращивать. Сейчас, например, у меня замечательное совершенно занятие, я созваниваюсь с евроновцами, со всеми евроновцами,
Мгм.
питчуем Руби Рашу и исподволь выясняю, есть ли у них что интересное, о чем они были бы готовы рассказать. Ну,
Блин. И как получается собрать?
созваниваться получается, собрать нет. Но я что-нибудь придумаю.
Мгм. А не все метапы же про Ruby, правильно?
Не
Там и
все.
будет,
У
и
нас
React
есть
какая-то.
Ruby, у нас есть Python, у нас есть Гошечка, и у нас есть фронтендик.
Мгм.
Причем горазработчиком в компании 3. Найди среди них спикер. Я уже одного нашел. Сейчас второго ищу. Возможно, не найду.
Жесть. У тебя бывает отпуск?
А,
Я просто не помню, когда, чтобы ты ходил в последний раз в отпуск. Такого.
иногда у компании, на которых я работаю, удается меня выпинать в отпуск. Но это тяжело. Я защищаюсь.
М.
Последний раз получилось 4 года, 5 лет назад в Оксампланте, когда владелец компании положил передо мной 2 заявления. Одно на отпуск, второе на увольнение.
Офигеть.
Попросил подписать вот на мой выбор одно из двух. Я решил, что мне нравится у них работать, поэтому выбрал отпуск. Вот. Ну, как бы... Возможно, в этом году Олег меня выпинает в отпуск.
Мне кажется, вполне возможно, да.
Он может. Тут, понимаешь, вопрос work-life balance, то есть насколько ты вот там разделяешь работу и не работу. Я не разделяю работу и не работу. У меня есть вот какой-то временной континуум, на
Мгм.
протяжении этого времени я занимаюсь штуками, которые мне интересны. Вот. И то есть нет какого-то там выделенного, знаешь, вот рабочее время и нерабочее время, там рабочий день и будний день.
Мгм.
Вот, они все для меня совершенно одинаковые. Но разница только в том, что там в выходные дни другие люди не созваниваются, хотя некоторые созваниваются,
Беда.
которые такие же, как я, большие любители. Ну вот. О, ты сделала апдейт, да, чтобы ему нотификация тренькнула.
А тебе тренькнуло?
Мне тренькнула. Я yes нажал.
Мгм. Ну ладно, ждем.
Я никуда не тороплюсь, думаю, мы его полчасика подождем.
Да
Я
я думаю, вообще без проблем, да. Я тоже.
вопрос почитаю, вспомню. Вот. Тут, конечно, немножко тяжело, потому что они формулировались письменно, а письменный и устный язык, они различаются.
Мгм.
Поэтому, если их буду просто зачитывать, будет, конечно, немножко крепота. Ну, он поймет, но будет крепота. Я очень надеюсь, что пока он отвечает на предыдущий вопрос, я смогу сформулировать, ну, я смогу прочитать и сформулировать следующий. Вот, для меня это довольно тяжело, потому что я туповат, у меня нет вот этого вот распараллеливания в голове, то есть я не могу одновременно думать две мысли, я не могу слушать человека, одновременно думать что-то еще. у меня процесс думания, он, как это правильнее сказать, а, выпихивает из моего сознания все остальное. То есть я могу думать, и когда я думаю, то я не могу одновременно с этим кого-то слушать там или что-то делать. Вот, мне нужна тишина, покой и то, над чем я думаю.
Мгм, я понимаю это. Да.
Я валидировал вопросы от Java Community. Java Community одобрила.
М, Отлично.
Ты, кстати, на Вирджинию Биовульф подписана?
Нет,
Мгм.
это кто?
Я почему-то думал, что ты на него подписана. Это такой лингвист и филолог, который жжет глаголом по английскому языку. Очень смешно и очень глубоко.
А
Вот.
можешь мне отправить
Да,
как-нибудь при
конечно.
случае?
Сейчас. Вот у него есть, не побоюсь этого слова, канал в телеге. Ты можешь туда зайти, и он дает просраться.
Спасибо.
Этот чел знает про английский гораздо больше, чем я знаю о программировании. Вот, причем я смотрел его видео на Ютубе, он не то чтобы очень старый, ему там меньше 40, сильно меньше 40.
Мгм.
А откуда он знает про английский столько, я себе не представляю. То есть это вот какие-то глубочайшие знания просто. То есть такое ощущение, что он 16 часов в день читает учебники, а остальное время снимает какие-то видюшки, пишет обучающий материал, зарабатывает деньги обучением, не спит.
Круто вообще.
Да, он дает просраться.
Так, ну, 5 минут.
Мы никуда не спешим, мы просто следующие 35 минут сидим на попе ровно и ждем потенциально гослинга.
Ну да. Вот Смота мне, кстати, пока не ответил. Я ему написала уже 2 раза.
Понимаю, это будет сложно.
Тоже открывает письма вроде бы, но не отвечает.
Ну, слушай, это не показатель. Это, может, не он открывает письма, а почтовый сервер открывает письма.
Может.
Ты же по трекингу видишь, что кто-то эти данные запросил. И, скорее всего, их запросила программа, а не человек телепатически подключился к почтовому серверу и начал байтики осознавать. И вот зачем программа эти данные запрашивает, мы не знаем. Мы можем догадываться, что для того, чтобы показать человеку. А может для того, чтобы положить в спам-фолдер. Или для того, чтобы там поместить в
Здесь
какую-нибудь
нет.
папочку low priority или еще чего-нибудь. То есть видел ли он, осознал ли он, это уже такая отдельная история.
М,
Если он придет, и мы все успешно запишем, я попробую Олегу Чурухину из Питера дать на расшифровку за какое-нибудь разумное количество денег, потому что Олег, он джавист, и он в прошлом интервью как-то участвовал, так что он знает, что как.
В прошлом интервью с Гослингом?
Да, который 1,5 года назад был.
Круто.
Я его смотрел, там довольно строго между нами оценочное суждение, там довольно средненько. Не ужас, но средненько. Вот есть интервью, которое мне прям нравится, там, с Дэвидом Ханиманом Хэнсоном одно очень хорошее. А то, что они с Гослингом, ну, такое. Какие-то, как это, капитанские вопросы, наполовину ответ самоочевидный, все его знают, на вторую половину очевидно он ответить не может или не захочет. Да. Бесполезно спрашивать, что ты думаешь про Kotlin, но как-то, что бы он ни думал про Kotlin, публично он это не скажет.
Ну да. Так, ну что?
Ну, нам еще полчаса на жопе ровно сидеть.
Кликнул.
Эх.
Ничего.
Сидим, ждем. Не волнуемся.
Не волнуйтесь. Oh my God. Hey, James.
Hello.
Nice to meet you. Can you hear us?
Yeah, I can hear you just fine.
It's
Thank you.
amazing.
Thank you for joining us. How are you?
Good. Good.
Yeah,
good.
my
So-
name is Elizabeth, and I'm that person who was sending you a lot of emails. And let me introduce you to my colleague. His name is Grigory, and he is working as developer relations at our company, and he's that person who was preparing all those questions for the interview.
Okay.
And we're super happy to have you here.
Well, thanks for inviting me.
First, obligatory question after thanking you for joining us in Java. How much time do we have?
I've got about an hour.
Okay, so I try to somehow prioritize the question, and if you feel tired or time runs out, please say us so we can stop the interview. Okay. First of all, why are we doing this interview? As software developers and software consultancy, we try to organize community in Russia. Python community, Ruby community, Java community, Go community, different community. And we want to help our fellow developers and create interview that highlight important questions for the industry. And I think that your experience and your work on Java can help our developers to, I don't know, become better, maybe. So let's try to help them. And I will ask some questions. And first, in your previous interviews, you admitted that if you could design Java over again, you would leave out classes and inheritance. Some languages like Go do exactly the same, while others experiment with features like traits, for example, in Rust. So as a language designer, what do you think is a modern, general purpose, a reasonable way for a programming language to do composition?
So I don't think I ever said I wouldn't do classes. I actually find that the classes work quite well for me for composition. I don't have any really good, clear ideas for what I would do differently. You know, and some of the things that I would do differently are a little strange. So like, you know, in C, there are macros, which are pretty much a disaster, because the macros are not a part of the language. They're kind of outside of it. The folks at Rust did a decent job of fitting macros into the language. But other languages, like, you know, pretty much all of the Lisp family, managed to fit them in more gracefully, but they had a way of defining syntax where the syntax was almost entirely free of semantics. And most languages, you know, the syntax and semantics kind of go hand in hand. And as somebody who in past lives has written a lot of Lisp, and I really addicted to the technique of using Lisp programs to manipulate Lisp programs. You know, that's one thing that I really miss. Some languages let you do that in different ways. So like in Groovy, you can directly play with the AST. And Rust has these sort of syntactically integrated macros. But it's always felt to me like there's an interesting research question in there, is that can you do more? You know, can I get kind of the feel of Lisp, you know, doing computations on code fragments to generate new code. And in the Java world, people kind of do that. It's one of the more popular features, except that it's really low level, right? Because people use a combination of annotations and the fact that you can generate bytecodes with some of the different languages. And that is super powerful. you know, and it gets used in places like that you wouldn't expect, like in Jackson, it gets a lot of its performance by sort of computing the serializer. And, you know, on the one hand, you know, really powerful technique. On the other hand, just super hard to use. You know, the fact that it's possible is great, but, you know, how far you can go is, you know, they can be kind of limited. So if you look at something like Lombok, Lombok is one of these things that I find to be, I have a strong sort of love-hate for it because it, you know, adds a bunch of Java features that are basically pretty nice. On the other hand, it sort of shows kind of a weakness, partly in the process, in that you know, this is, you know, a set of features that should just be built in, guys, you know. And the you know, the Java community process has become, you know, somewhat less community than it should be. And, you know, I'm kind of on the outside these days and have been for quite a few years. But, you know, there's you know, things you could do that are just all over the map.
That's why I arranged questions about your amazing experience with creating them, not with some modern Java enhancement proposal. And yeah, 5 years ago, I can confess I manipulated some Java bytecode for good, of course, but creating domain-specific languages out of them is kind of tricky. With Ruby, it's much easier. We at Evron Font with Ruby, we have dozens of Ruby developers, and yes, Ruby developers are great, but they require lots and lots of years of training to learn all the DSL magic. And
yeah, so just one thing. I mean, one of the things that's, you know, with features like this of, you know, like computing code fragments, the thing that makes the reason that it's kind of awkward in Java is that Java tries to go all the way to compiled machine code. And Ruby is pretty much always interpreted. And when you're doing that, when you're not trying to get like all the performance that you can, then life is easy. But if you're trying to get both powerful features and ultimate performance, then life becomes much, much harder.
Yeah, recently I interviewed Yukihiro Matsumoto, author of Ruby, and he mentioned that he performed an experiment with his latest major Ruby 3.0 version. He tried to release this version without breaking changes in order to see what will happen. A major language version that doesn't break anything. And he succeeded. And now he thinks that it's a viable solution for a language to improve its syntax, standard library, runtime without breaking a lot of things. From your experience as a language designer, I know that Java is very careful on not breaking things. Is it a good idea for all languages to evolve without incompatibilities, or it is a limited approach that can be used only for specific languages like Ruby or Java maybe, and can't be used widely?
It is almost entirely a function of the size of the developer community, right? Every breaking change induces pain in the developer community. If you don't have many developers, then, you know, breaking changes aren't a big problem. And you also have to do this like cost benefit trade-off. You know, if you do a breaking change, you know, it adds some pain, but it also brings some benefit. You know, so if you did something, something like you change the subscript operator from square brackets to round brackets, it probably buys you absolutely nothing, and yet induces terrific pain. So that would be a dumb idea. In JDK 9, there was a change introduced, and it was like one of the very few breaking changes that are ever introduced. But what it broke was people who were already breaking the rules, right? If you were using some of the supposedly hidden APIs, really what happened was that the encapsulation mechanisms got stronger. And people who were breaking encapsulation boundaries and using things that they shouldn't have been using in ways that they shouldn't have been using, they had some pain going from 8 to 9. But once we get beyond that, that gives the platform a lot more freedom to innovate. And in particular, it means that the platform, you know, in the particular case of the 8 to 9 transition, the platform could be sliced and diced. So you could actually make, you know, custom packagings of the Java runtime environment that were smaller. And one other area where there's always a fair amount of discomfort is when there's a bug in something and people do workarounds for the bug. And then if you fix the bug, you may break the workarounds. And, you know, there have certainly been instances in the Java world where we've decided to either not fix bugs or sort of finessing the question by not fixing the bug, but by introducing a new method that does the correct thing. And, you know, that even shows up in hardware. There was an issue with sine and cosine and on Intel hardware that, you know, they were slightly incorrect. And so they now have the correct and the incorrect instructions.
Yeah, I remember 20 years ago when I worked on the Redmin remote control software, we suddenly realized that one of Windows versions inside the kernel was a workaround for older Redmin version, just to keep backward compatibility. That was strange to find it. And also 25 years ago, when I started my own career as a software developer, I written a lot of C and C++ code. And I remember these mystery pointer bugs that happened sometimes in between threads, logs, critical section once in a week or once in a month. Debugging such bugs was a pain. But now, as a software developer, I see lots of tools integrated into our workflow, and I'm talking about static type checkers. Modern developer, they start IDE like NetBeans or JetBrains IDEA or even Visual Studio Code. They write the source code, and static type checker, it parse entire program, construct abstract syntax tree, and check everything it can, and it just highlight possible errors. And such tricks, they are available not only for statically typed languages, but even for dynamically typed languages like Python, Ruby, TypeScript. There are static type checkers available right now. So what is your opinion on these static type checkers that we use today? Are they a step forward to write better software, or they're just a kludge and we need to put more inside the language?
Well, a bit of both, right? So one of the reasons that I'm a big fan of languages with static type, with good type systems, is that they provide the scaffolding for the static type checkers in the IDEs to work. You know, I spend most of my life as a software engineer. The least satisfying way for me to spend my time is hunting down obscure bugs that happen at weird times. And anything I can do to make bugs disappear before they waste my time is a good thing. So I'm a big fan of just about anything that an IDE can do to reduce the probability of a bug. And so when you look at the dynamically typed languages like JavaScript and Python, they have less of an inference framework to work off of, because they don't necessarily know what the type of anything is. They're just kind of guessing. Strongly typed languages like Java, they provide a much more rigorous framework for the type checkers to use. And going up another level, there are things that do like full up theorem proving. So there are systems like Daphne, which has a really sophisticated theorem prover in it, so that if you want to build, say, an encryption algorithm and be able to, mathematically prove properties, you can do that. And that might be a little too far, but for some code, it's really, really, really useful. And a lot depends on what your goal is, really, in that, if you're, say, a university student and you're just trying to get your assignment done, or you're a PhD student and you're trying to graduate, then when you write a program, your goal is that it should work once, at least once, right? Because you have to do a demo and be able to show it off and say, see, this works. If you're in an industrial setting, like where I've been most of my life, working once is only slightly useful. It has to work every time. And the difference between working once and working every time is huge. And so if it only needs to work once, then the more dynamic languages work reasonably well. If you have to be sure that it's going to work over and over and over again, all of the static typing tools help you, come to that confidence. But if the kind of thing you're doing is like say you're a physicist and you want to find out, you know, the result of some computation, it only needs to run once. So, you know, it depends on some kind of the context of the work that you're doing. And, you know, the more reliability you need out of the software, the more that a statically typed language helps.
Talking about enterprise and industrial development. I never programmed robots myself, but I took my time working for companies that create software for millions of people. And I can compare today and 20 years ago, 25 years ago. And I see that right now, social coding platforms like GitHub, they are backed by big companies and they help with open source development for both individual developers and enterprise and industrial software developers. So can we call today the golden age of open source software, or it's not that clear? What do you think about GitHub?
I have no idea, right? I mean, you know, you're asking a question about the future, right? And you know, the problem of the question of is today the golden age? That question implicitly says, is it downhill from here? Right? Because if this is the golden age, then tomorrow's got to be, you know, not so golden. Right. And personally, I think we're just leading up to it, whatever the golden age is. You know, I think that there's a lot of really interesting improvement that can happen. I mean, you know, currently we're having all kinds of crises around security and the ways in which people are able to do, you know, cyber terrorism. And boy, oh boy, you know, when that kind of stuff is going on, I don't think that's a golden age. You know, once, you know, if there's some way that the collaboration of communities of people can lead to the end of cyber terrorism, that would be pretty golden. So we'll see. I mean, this is a really great time, but it could be better.
Yeah, I saw recently that GitHub, they introduced even automatic testing for vulnerabilities. So if some developer, we have Python or Ruby or C project, bot from GitHub comes and automatically shows them like security vulnerability in your dependencies, security vulnerability in your source code, please fix, and so on. That's a pretty good thing to have. A question about past and PhD theses. It's hard for Russian person to pronounce theses and theses. They just break my jaw, but I will try. So you created Java and JVM, Java Virtual Machine, with JIT, just-in-time compilation. And this just-in-time compilation provides a really amazing speed while keeping language syntax pleasant and high level. Many languages, they followed your lead, like C#, JavaScript, and the speed of compiled and recompiled code over hot paths. It's amazing. We rival C and C++. But many other languages, Python, Ruby, PHP, they have optional JIT, but it's not popular. And many mainstream languages, they do not use JIT to get this tenfold 100-fold speed. Why do you think is it? Why not all languages use JIT to provide amazing speed for software developers?
Well, so to really get the performance improvements that you see, it helps dramatically to have a statically typed language.
Mm.
For the dynamically typed languages like Python, it's really, really hard. And often what people end up doing is they start adding annotations to the language. So you get languages like TypeScript, which is essentially JavaScript with type annotations. And it's really funny because JavaScript is essentially Java with the type declarations removed. So TypeScript is essentially Java with sort of syntax kind of permuted, right? It's, you know, the way they've got sort of Pascal style declarations. But, you know, if you're somebody who's just, you know, slapping together quick scripts in Python, a lot of people in that world find declarations to be annoying, and sort of thinking about the types of their variables to be annoying. You know, in Python in general, and in many of these, there's only one kind of number, right? And that's the, you know, the double precision floating point. You know, there are no true integers. There are no, you know, bytes and 16-bit integers, things like that, which conceptually add complexity, but they also improve performance, right? So if you've got, say, you know, double precision floating point versus single precision floating point, there's sort of a cognitive burden in that. You know, in order to make intelligent trade-offs, you have to understand a little bit about numerical analysis. And I know it is reasonably common for people who are software engineers to know almost nothing about numerical analysis. And so they would just rather not think about it. And if you're say a physicist using Python, you probably want all the precision you can get almost always, unless of course you need to put like a really big array in memory where the difference between single precision and double precision or an 8-bit integer, it really matters. But if you're living in a space that's where none of those things are really of any consequence, you know, it's just easier for folks. But if you need to care, and you know, I've taken too many numerical analysis courses in my lifetime and been burned by, you know, shoddy numerical analysis enough times, that I tend to care. So, you know, it kind of depends on where you are in the spectrum, and most people in the sort of scripting language world, they don't care about that sort of problem. Their concerns are at a very different level. And, you know, for a lot of people, they don't actually care about performance numbers in detail. What they care about is it fast enough? You know, performance is kind of a Boolean. You know, it's fast enough or it's not fast enough. For some people, you know, it's more like, you know, tuning a race car. You know, if you can get an extra 2 or 3 miles per hour out of a car, then you're more likely to win the race.
Yeah. I remember few months ago, David Honeyman Hansen, author of Ruby on Rails, one of the widely popular web frameworks, he complained or just mentioned that only 15% of his cloud budget goes toward language itself. Rest are some cache levels, message queues, storage, and so on. And he told us that notion that Ruby is slow, it's not very relevant because, okay, if Ruby is 100 times faster, what will change? It's just 15% of his budget. Okay, it will be 1.5% of his budget. Nothing will change. So yeah, they are mostly fast enough.
Well, and that depends a lot on where, where in the sort of space of programs your task is, right? So if the thing you're trying to accomplish is really dominated by networking and databases and all the rest of that, if you're doing RPCs all the time, probably the first thing you should do is question whether or not all of those RPCs are valuable. I mean, I find it, when people talk about like microservices, they're a fine thing, but just understand that they're like a factor of 1 million at least slower than a method call. So just think through the implications of that. And usually for most people, they'll get a lot more performance bang out of making sure that their large scale architecture is clean. But there are a lot of folks for whom all of the low level details really do matter, right? If being highly concurrent, being able to drive thousands of processes or hundreds of processes at once, doing major computation. If you're doing something like a database itself, or a major storage service, you really, really care. So it all depends on the task at hand.
Recently, I saw lots of languages embrace coroutines and async await approach to handle the network, which is slow, and all the weight in the application. So async await, it was added to Python, it was added into recent Ruby, into JavaScript, into many languages. But with async await and coroutines and scheduler in one thread, they are not silver bullets. They come with their own complications, and sometimes they can make software slower, not faster. So what do you think about this modern async await hype? Is it a good way to handle network, or we just mislead it and we need to check Erlang and other approaches?
Well, so again, this is one of the sorts of things where context is everything, right? So coroutines are perfectly fine. They've been around since the 60s. The first language with coroutines in them was Simula 67. And Simula was a lovely language. I still miss it. And it didn't have threads, it had coroutines, but the way that they did coroutines, they look a lot like threads. And coroutines, you kind of magically sidestep some of the naughty issues in true parallelism. And for me, one of the problems with coroutines, which is why I haven't used them in a long time, is that they don't actually let you do or let you take advantage of multiple processors. You can't do true parallelism. So, people look at, the things that people in languages that have true parallelism, like Erlang and Java, the things that you have to do that add, another level of complexity. Although often the way you deal with that complexity is by having very carefully curated primitives, like some of the things that you can do with concurrent hash maps in Java is just magical. But as soon as you've got one of these coroutine based languages and you try to exploit multiple processors, right? So if you're doing a lot of coroutine type operations and you don't have enough processor, you're saturating the one processor, and you would really like to be using multiple processors because there are no uniprocessors in the world anymore, right? I mean, everything's got a lot of cores. And if you really want to use all of your computer at once on one problem, you just have to bite the bullet and handle the complexity inherent in multi-threading, in true multi-threading. So, then there's the issue of like what style, right? So the ones where there are contexts, which is where you can say await this and await that, where they do this, kind of in transparent inversion of control, where you're sort of passively yielding. That gives you a syntactic appearance that looks a lot like true threading. But it means that a lot of the tricky bits in true threading you get to avoid, right? So if you say A equals A plus 1, you know that in the middle of that operation, you're not going to get interrupted. So you don't have to do synchronization. But then there are other places where instead of doing that kind of style, it becomes an event-directed style, where you do your thing and then you plug an event handler into something to handle what happens when things complete, and that tends to be the predominant style in JavaScript. That works perfectly well, but it can get kind of clunky, and certainly, when I discovered Simula back in the early 70s, early 70s, the sort of natural style, you just program, and if so you can think of your computation as a self-contained thing, and whether or not other things interleave with it is kind of transparent to you. I found that as a conceptual model to be much cleaner than event programming. It's tougher to implement under the covers, but it's usually easier to think about.
It's a first object-oriented language after all. I never had the chance to work with it, but I checked the documentation, and it looks featureful for its years. And if we check some modern language like Ruby, concurrency model is really complex. We have processes, individual interpreters within processes, threads within individual interpreters, and coroutines within threads, like a Russian doll. I have a non-technical question, if you allow. So if we talk about different languages, from your personal opinion, what is the best language we want to teach new software developers right now as their first language? Maybe in grad school or university, I don't know, but what language should it be?
Well, I'm clearly biased. And, Java has been used really successfully that way for quite a long time. But, the first programming language I learned was PDP-8 assembly code, and followed roughly concurrently with Fortran. And you can teach people just about anything and it'll get through. Some of them are a lot easier than others. But a lot depends on, what the eventual career path of the people is going to be. If you're going to be a full-up software developer where you're building sort of big high-performance systems, it's hard to beat any of the languages that run on the JVM. And I actually don't care which language you use on the JVM. I mean, Scala and Kotlin are both fine. Clojure is really entertaining, but you have to really think differently. If you're a physics student, Python's fine. And I don't think it's actually that big a deal which one you choose. Although a lot of people, it's like they just stick with the first thing they learned and do that. If you can get people to learn multiple languages and go back and forth, a really nice course that every university should be offering to like every student is like a comparative programming languages course. Where in the course of the semester, you have 5 assignments in 5 different programming languages, and that gets people to sort of get used to the ability to learn them quickly, because they really are not all that different, and to think about which ones are better. I know that I took one of these courses a very long time ago, and I made a point of using the absolute worst language for every assignment, so doing numerical computing in COBOL.
That's
was entertaining, and symbolic manipulation in Fortran. Surprisingly, I still got an A.
As expected. Do we have some more time for a few questions?
Yeah, I can manage a couple more.
Thank you. So, pattern matching recently gloriously landed in Python, Ruby, lots of proposals in different languages. I checked the white papers, developer white papers, and they are not entirely sure what's the role of pattern matching in a modern high-level language like Python, Ruby, or Java maybe. This pattern matching idea, how do you think it fits the tool belt for ordinary modern developer who works with Java or Python or Ruby or some high-level language? Do we really need pattern matching, or it's some niche syntax for very specific use cases?
Well, so for starters, I think that the term pattern matching in programming languages is somewhat misleading. You know, because when I hear the phrase pattern matching, the thing that springs to my mind are things like regular expressions, whether they're regular expressions over character strings or regular expressions over trees. Yeah, they're you know, pattern matchers over tree shapes, whatever. But so going back to Simula, Simula had an inspect statement. And the inspect statement was almost exactly what many of these pattern matching statements are. Namely, an inspect statement is a case statement where the case labels are type names. So you'd say inspect P when image do when vector do and so if you're so you can think of it as a case statement that cases on the type. And most of these pattern matching language proposals are more of that kind of thing. And personally, I miss that. I really like that, especially if what happens is it's like an implicit cast in C. So if you say inspect P when image, you know, P dot paint something or other, right? So that P become, you know, within the body of the case statement is now the type of the switch label or the case label. That makes life so much easier, right? There are all these places where you know, in a language with a C-like syntax, you end up with casts all the time. And it boasts, you know, it's sort of like a, you know, if A is instance of X, else if A is instance of Y, and then a bunch of casts in there, right? And the inspect statement in Simula was just beautiful. I loved it. I have missed it every day since then. And a lot of these pattern matching proposals and language features kind of look like that. And so if you call them like a type case, something like that, great idea. You know, if you call it pattern matching and it has like less power than a regular expression, then yeah, that feels kind of like false advertising or misleading. But as just a feature, I think it's great.
Okay, our time runs short, and I think I will ask our last question. It's like an obligatory question. Russian software developers, we are proud of JetBrains and their Kotlin development. But of course, I will not ask some trivial things like Java versus Kotlin and so on. I will try to ask differently. Kotlin and many other languages like Clojure, Scala, they thrive on existing Java virtual machine that you created and existing ecosystem of libraries, of frameworks, of existing code. Is it any theme, any challenge that all such languages face? Is it something that unites them, some difficulty for them if they're trying to hot swap Java syntax with some different syntax? What challenges do they face on this way?
What challenges do they face? again, kind of depends on what you're trying to do. So one of the peculiarities of the Java virtual machine is that there are a bunch of notions of security and reliability built into it. And they have to do mostly with the integrity of the memory model and pointers and things like that. So you cannot forge a pointer. So if you look at languages like C, if you didn't have the ability to forge pointers, you can't do C. So there are some virtual machines out there where they don't have a tight security model. So on something like the JVM, if you try to implement C, and some people have done it, although it's odd, you really, there are places you just can't go if you've got a rigorously secure virtual machine. And some folks have built, virtual machines that are not rigorously secure, that don't have like a memory allocation model. So if you don't care about security, if you want to be able to do interoperability between C and Kotlin, you have to be willing to give up a certain amount of security and reliability. And so it depends on where you're willing to go. And certainly, at the dawn of Java, one of my personal rules was, I do not want to have to debug another freaking memory corruption bug, because I had wasted way too much of my life on obscure memory corruption bugs that take you days, and it's just off by one error in a loop that just happened to go one entry off the end of an array, and you didn't find out until like millions of instructions later. And I really, really hate chasing memory corruption bugs. So, if it depends on what you're comfortable with. Some people, think of spending time doing that as like being very manly. But then there are people who like to use VI, which is a great editor in the 70s and a good editor in the 80s. But, come on, folks.
Yeah, the security, memory security model is indeed in the core, and it provides something, but limits something else. James, thank you a lot. It was a pleasure to have this conversation with you, and I hope that after all this zombie apocalypse ends, we will be able to meet each other in person at some conference, offline conference, I hope. So best health for you, and
thank you.
Have a nice day.
Yeah, you too. Thanks. Bye. Thank you.
Thank you. Bye-bye.
Bye.
Вот, поздравляю, у нас все получилось. Я пронавигировал на вопросы.
Говорю спасибо.
Да, и пока он отвечал, я смотрел, какой следующий вопрос можно как-то вплести в канву, чтобы они уложились в час. Но вот у нас получилось 9 вопросов, это неплохо.
Ну да, отлично.
Смотрим, сколько из них уйдут в прод, но он там наговорил интересное. Значит, наши дальнейшие действия. Пожалуйста, возьми вот этот вот ролик, сделай, выложи его на YouTube Unlisted и дай мне ссылку. А я попробую его запихнуть в Олега нашего Чарухина, чтобы он сделал, знаешь, тут надо не просто расшифровку, тут нужно, чтобы человек, который джавист, сел и аккуратненько сделал вот такую креативную историю.
Ты хочешь, чтобы он на английском сразу сделал?
Ну, естественно.
Я просто сама планировала сейчас расшифровывать это.
Ох, слушай, ну
Как
тебе
лучше
тяжело
делаем?
будет. Ты уверена, что хочешь этим заняться? Потому что у него там много программерских нюансов. Вот, и потом смотри, у нас же по сути равки. То есть у меня raw English и у него raw English. Чтобы из этого сделать текст, нам его нужно, преобразовать. Потому что у нас же с ним разговорный английский, а у меня еще кривой разговорный английский. И из разговорного английского сделать статью, тут нужна, как это называется, рерайтинг. Вот,
Но мы можем сделать так, что, допустим, я расшифрую, а потом он отредактирует, либо наоборот, он сделает, а я потом красиво это перепишу. Как лучше сделать, как думаешь?
Смотри, я думаю, что лучше всего, чтобы он сделал текст, вот, из звука сделал текст. У него, конечно, будет корявый английский текст, а ты уже сможешь заняться этим английским текстом, который будет корявый, но технически корректный.
Ну да, давай так лучше. Да.
Вот, дай мне, пожалуйста, несколько дней, я попробую это запихнуть в Олега, то есть не факт, что у него получится. Вот, если у него не получится, фалбэкаемся, как обычно, ты расшифровываешь, я редачу.
Окей.
Это, конечно, будет бобо, но ради Джеймса нашего Гослинга можно и не поспать пару дней.
Ну да.
Все, жду от тебя ссылочку на запись.
Окей, хорошо. А ты не знаешь, вот это же Анин аккаунт, наверное, ей придет запись?
Да, Аня придет, все.
Все отлично, тогда сейчас я...
Вот, скачивай, перевыкладывай на YouTube Unlisted и давай мне ссылку.
Хорошо, ладно.
Спасибо тебе огромное.
Тебе спасибо.
Я делал, тоже, конечно, сложную часть, но я делал часть, которая хотя бы manageable. А вот добраться до него, чтобы он в этом поучаствовал, это реально прям вот трики.
Да, все здесь трики, пообщаться и добраться. Так что...
Трики. Все, бай-бай.
Пока.